All right, what's going on, everyone? Welcome to more developing. Another developing stream. We're going to switch to different units to represent temperature because apparently there's no way to measure temperature in newtons yet. Anyways. Yeah. Well, probably going to be a pretty easy change, so might not be the only thing we do. But I'm also trying to remember right now where we were last time. Okay, well here, I know I switched, I added like a force amount and a force direction here. Let me do that. And I'm assuming when we create the initial collisions on entity, probably have to set the direction or something like that, at least. I would imagine. It would be an integrate forces. Are we not setting the... Okay, we're setting the force here. Yeah, we can just do this and then normalize. And then reactant dot force equals force dot x plus force dot y. Or I guess I could say force dot length, right? I just want to make sure that is a member I can use. Okay. So I'm noticing that we are setting the force multiple times in this for some reason. Oh. I see. Yeah, this is temporary. This is if we're colliding with like the dragon. Okay. We're also trying to incorporate the atmosphere here. Did I even do the calculation yet? Maybe not. Well, if I remember correctly, the formula was density times depth times the acceleration of gravity. It's just, I don't know. I don't know if that's going to give us the result in newtons, right? In pascals, I guess. Or whatever, like, newtons per square inch would be. Yeah. I guess for now we could just approximate it with that. Oh, but we also need to be able to get the density of the component, right? Which is returning 0 right now. Which leads us to temperature. Okay. I guess we'll measure in Celsius. Why not? And then in our elements, we're going to need a melting and boiling temperature. Did I say degrees Celsius? Would that make more sense? I feel like I need the little icon or something. I really hope the system just ends up working. What is the melting temperature of oxygen? Also, what is the max value of a float? I see. So I could set these both to this value, which would basically make it impossible to melt these. I guess not impossible. Like, if for some reason it's able to get to this value, then, that might work. But that kind of means that everything is going to be solid by default. So I guess we just have to rearrange things. Oh, it even says infinite. Okay. Interesting. Well, what is the boiling temperature of oxygen? Negative 183 degrees. Melt. Can we get the melting temperature of oxygen? No way. Can you solidify oxygen on Earth? It's not that much cooler. It's negative 218.8. What's actually, well, I mean, the number goes on forever, but we're approximating here. I don't really want it to be able to melt, though, in game. Or, solidify or boil, actually. Huh. Should I add a boolean for that? I think I should. Can be liquid. Boolean equals. Perfect. False. Can be solid. Can be gas up here. And I think I'm just going to use the default export for this. I'm trying to keep the system as cool as possible. Is it actually applying the changes? Do I need to reopen this? Okay. Can be gas is true. I'm only going to worry about gas right now. Water can be liquid, can be solid, I guess. I guess we'd have to do that for, ice. Unless we want to use a different element. Which, we don't want to use different elements for those sorts of things, because we do want to have the functionality of being able to, like, melt ore and then reform the ore. Maybe. I don't know. Again, I could encounter like some massive theoretical problem that just like stops me in my tracks. But until then, we're proceeding with this monstrosity of game development. And let me set the melting temperature. Well, the melting temperature would be 0, right? What is the boiling temperature? 212 degrees. This Fahrenheit. 100 degrees Celsius. Right, that's like what the whole Celsius scale is based off of, right? If I remember correctly. Can be gas? That would be like steam, basically. I guess we can do all three for water. Ash. That can only be solid. At least for now. Wood can only be solid. I'm pretty sure I'm not going to change that one. Okay, so if we can think of elements as like data containers, we can think of components as like implementers, sort of. I guess we do kind of have to get the state. We might need some sort of data containers to represent the actual states. I guess we could start in that regard with like an enum. Solid, liquid. Or how about we, no, that would be in order from like lowest temperature to highest temperature in general. And again, my brain keeps getting confused with Lua. So I'm doing some Lua things here and there, like the equals. I think I did that because with Lua, you basically have to like give everything a value anytime you declare a variable or like anything ever. There's a lot of assignment operators in Lua. You know, as long as you can like keep your head like wrapped around, this is figuratively wrapped around whatever you're working on in Lua, you can actually at least in Roblox Studio, the most what's the word? Is it eclectic? Hold on, I need to get this right. Yes, the most eclectic choice of game engine. It allows you to iterate really fast on like different things, different concepts, different ideas, and you can incorporate them. You can innovate. It maximizes the speed at which you can innovate and inspire. Okay, we'll have a get state function, which will return element dot state. Why is it not letting me access it? Maybe it will. Also, I think I kind of named it wrong. think it has to be like that. Yeah. Okay, well now it seems to be popping up. If temperature... Okay, if element dot can be solid and temperature greater than, or temperature is less than element dot melting point, melting temperature, return element dot state dot solid. Else if element dot can be gas and temperature is less than element dot boiling temperature. Wait, what is this? Oh, what? I think it can be liquid for this part. Return element dot state dot liquid, and then down here we just return element dot state dot gas because there's nothing left to do. Now we can use that in a switch statement or a match statement. And I'm forgetting the syntax for that as well. Solid density, yeah. Do we even have like a gas density yet? I don't know. Don't think so. I think we do have a gas density though. Okay. Um, I guess I should add that. It still says solid density. Oh, I guess that doesn't make sense for the suffix. Okay, go back to oxygen. Gas, liquid, solid, okay. Density of gas. I guess each state could also be like its own object, so we don't have to like do a branch every time. That will probably be the better way to do it. We could use some sort of like ref counted object for that. I just looked up density of gas. Oh god. Isn't grams per liter like basically the same as grams per centimeter cubed? What is a liter? What is a liter? 1 kilogram of water under standard conditions now equal to 1,000 cubic centimeters. So 1 cubic meter. No, 10 cubic meters? 1,000 centimeters in meters. Yeah, it'd be 10 cubic meters. Right? Do I already have the value for this? I feel like I should already have the value for this. Okay, maybe not. feel like I did add this somewhere already. Okay, well, maybe not. Value is 1,429. That doesn't sound right, though. And I'm trying to remember how I calculated the density of aerogel. What was it, like 1,600 or something like that? That doesn't sound right. I'm gonna stick with this, though, because I think this is correct. And I should probably put the checkboxes under the respective categories. Yeah, that's a bit more organized. Go back to component. Okay, now we can, like, completely get the density. And I think the temperature of the components, we're not really setting that in any way. So, um, I mean, it can only be a gas anyways. We should be fine. Although I don't know if we're going to have fluctuations in, well, we are going to have fluctuations in density based off of temperature. That is something I wanted to add, at least for gases. Because that's the only way we can have, like, the hot air balloon thing, right? All right, let's go back to the atmosphere. We're going into the atmosphere. Here we go. Um, Variable force equals height. Height times gravity times the density, right? Component get density. And then the force direction will just set to, well, it's pressure, right? So the direction we want it to be is 0. That's why we adjusted the system to be able to do that, to be able to make that distinction. Okay. This is a node 2D, so for singleton. Here, let me, can I use the initialize function? That's gotta work. Singleton equals self. Okay, now we just add the atmosphere node in. System can be a new, do we not have contiguous system? What? Is there an error that I haven't fixed yet? There might be. Yeah. Oh, but then how are we gonna determine that for pressure? Maybe I should just separate the values completely. Like force can be a vector. Pressure can be a number. Because I feel like this might just destroy everything. Because the atmosphere, the pressure is gonna be like really high. I feel like our values are gonna give us something kind of crazy here. Is that really how much force it would be applying? I don't know. How to calculate atmospheric pressure. This is the hydrostatic formula or whatever, right? Does it have to be in kilometers? I don't know. Also, does this calculate in atmospheres? I'm not sure. Let's try this. Wait, I don't even know if it's gonna work. Oh, shoot. I think we do want to add it to... Entity? Yeah. And I might want to make those functions static. Didn't even copy it correctly. That's funny. Single V8. So true. Okay, at this point, probably just append it here. So, atmosphere dot add to collision, chemical collision. See what that does. It's gonna destroy. It's gonna immediately destroy all barrels. That's what it's gonna do. Well, we probably have to touch them first. But all barrels might immediately get destroyed now. I don't know. It's gonna depend what the force values are, which, again, should be pretty high. Like, is it even proportionally consistent with that formula I'm using? Don't know. Like, do all of those values contribute an equal amount? Also, why am I not getting any stuff? I should probably run through GD script. Yeah. I don't know if I'm gonna bother with the guitar right now. Is there anything to talk about? Jeez. I don't know. I'm trying coconut pear Burt's Bees. It's not as good as the cucumber mint. Quite frankly. It's actually a little bit off-putting. But it works well enough. I guess I'd prefer it to no flavor. I need to be able to eat my chapstick somehow. Well, no, I'm not gonna do... Wait, hold on. Isn't chapstick a brand name? I'm not gonna do the thing where everyone calls adhesive bandages band-aids now. Or maybe that's a good thing, right? Because it dissolves all the meaning of the brand name. No, I don't know. I would say I guess it's a good thing, just on the basis of like having one common definition for this thing that people can use to help them. I figured it. I cracked the code. I figured it out. All right, is anything gonna happen here? No. No. Wait, I don't think I made a contiguous system. Yeah. Get over here, atmosphere. Contiguous system. We're going to add a new component with oxygen. So right now the atmosphere is going to be made up of 100% oxygen. Does this mean that the atmosphere itself is combustible? I do not know. I really don't know. We'll figure it out. Can the atmosphere catch on fire? We're gonna find out. Should we be able to specify the density with this kind of stuff? I don't know. I am extremely high energy today. Nothing can stop me. I'm like a train going at 1,000,000,000 miles per hour. Okay? You could lay a brick wall in front of me on the tracks. It's not going to change my speed at all. In fact, it'll probably make me faster due to the energy transfer that is received from the kinetic impact with the bricks. That's how energy efficient this system is. Okay? I've never been tired a day in my life. This concept is completely alien to me. I don't. What is fatigue? What is exhaustion? I don't know what these things are. My mind is unlimited. I'm never tired. Okay, what's gonna happen? What's gonna happen here? Invalid access to property or key component on a base object of type node 2D. You know, that, it's kind of dumb. But I understand. Did anyone see the, wait, what was it? Oh yeah, the Fallout Season 2 trailer yet? The teaser trailer didn't really show anything about the plot, which is kind of annoying. First one was kind of cool because it had, like, lots of spinniness going on. Like, and the like, the parallel plot. Or I guess it wasn't really, depends on how you want to define it. I guess it was, like, chronologically, you know, at different times, but the whole, like, going back to the pre-war world and seeing everything that was going on there through the eyes of this guy who happens to be, like, involved in everything that goes on with, like, the global elite for some reason, and it also happens to be the cool guy with the gun in the post-apocalyptic setting who turns into a ghoul. You get to see it all through his eyes. You learn a lot of interesting stuff throughout it. And they definitely, I think, if I remember correctly, they left it off in a spot where they could, like, continue that in the first season. Like, they left some loose ends, some cliffhanger elements, if I remember correctly. You know, I have high expectations for that. Well, moderate high expectations. I don't know. The first season was good, so I expect the second season will be at least 70% good. Well, I can't even do that. Okay, like a worst case scenario, it's like 20% is good. Best case scenario, it's like 150% is good. So you take the middle value of that. That's what I think it's going to be. There you go. We don't have words for these things. Going to return an array of type array where expected return type is array string. Really? Reaction rules. I guess I'd have to cast it, huh? Okay. Just an array then. Oh my god. Um Trying to think of other things to talk about. I have this fake $1 million bill. I wonder if it has any interaction with like the light or shining a light through it. Hold on. Shining a light directly into my face. There we go. Finally, I have good lighting. Let me see. I can't tell. I can't tell if there's anything going on here. Maybe? No, I think I'm just seeing the other side of it. Yeah, yeah. Very lame. Okay, there we go. Finally. So we are now translating the force over, and it's like a lot. It's a lot. That's what it is. I mean, we are using 100 kilometers. Wouldn't that be what it is, though? I mean, we would have to divide this by the surface area, but even if we did that, it's still going to be a very large number. So I think our equation itself is probably not correct. We might have to change some of the variables we're using to begin with. So I guess I should do more research. But once we get a value that's like within the realm of reason, well, hold on. When I was looking at the density of oxygen before, that was like just pure oxygen, right? It shouldn't be. It still wouldn't fix it though, even if I like reduce the density of it, because we're using such large numbers here. Oh my god. The atmospheric pressure at sea level is 100,000 pascals. Maybe we're not too far off. Um, it's it's Newton per meter squared, like 100,000 at sea level. That's kind of crazy. I must be like misunderstanding this or something. Because we also have like the tensile strength or whatever, right? Wood, which is only that. So is that really correct? What is the pressure of 1 atmosphere? Oh my god. Something I'm misunderstanding here? There's got to be things that crumple under the weight. Well, anything that would crumple under the weight of like atmospheric pressure on Earth would probably just crumple under its own weight with gravity, right? Am I misunderstanding how pressure works? Oh, jeez. Maybe I'm misunderstanding pascals? 1 per square meter. Yeah, it seems like a lot. How is everything not imploding if the atmospheric pressure is so high? No, that can't be right. Really? Me figuring out what pressure is? Oh my god. Oh, because, like, other stuff has entered it or whatever. Yeah. Okay. So in the case of the barrel, I mean, if the barrel had nothing in it, then it would. Oh, then it would crush. Okay. Right. Internal pressure. It's like a thing. So we somehow need to compare the internal pressure with the external pressure. Something like that. And we're doing everything as amounts right now. I guess. I guess that's feasible enough. Guys, I'm so energized right. Oh, whoa, I'm I feel unstoppable. As a matter of fact. No, this is probably not going to be a very long stream. Okay, well, we just have to calculate the internal pressure. That's all. So if something was on Earth, and it had nothing inside of it, it would be subjected to that much pressure. That's like a lot. How much atmospheric pressure would be exerted on something with nothing in it? I guess that makes sense. It's kind of crazy, though. Right, any air that would enter something would naturally be higher pressure. Yeah, that makes sense, which is why the gas density of everything we looked at is like, oh, under the Earth circumstances. Oh my god, it's a whole thing. There's a whole thing going on here. With like atmospheres and stuff. Hmm. Should I just not apply force? Maybe. Or like very little pressure? The thing is, it's like it is going to be applying pressure, or it is going to be applying force, but there's also there's like an outwards force coming from the inside of the object. So there would still be molecules touching it. It's just it would be like evened out. I mean, yeah, something like that. Does wood have air in it? Is wood porous enough to have air? Probably, yeah. Probably some level of air in wood. What about like rocks? I don't know. Maybe I should look that up. Do rocks have air in them? And it probably depends on the rock to a certain extent. Like porous rocks are obviously gonna have way more. Okay. Hmm. It's interesting. Yeah, so air pressure, I mean, atmospheric pressure is really strong, guys. That's what I'm learning from this. We need to balance it out somehow. But like a rock, a dense rock, how the hell is any outward whatever getting in that? Maybe that's just the amount it crumples to, you know? I don't know. How does this place work? Also trying to think how I'd represent the internal pressure. Like, again, I could just not include pressure in the calculations. I feel like it'd be feasible enough to determine the amount that the molecules are touching from the pressure, but I don't want it to act as like a force. Now, and if you increase the internal pressure, it expands, hence like a balloon, like a hot air balloon. So maybe we will need some measure or some way to measure internal pressure. Yeah. Okay, you know what? Hmm. I am a zombie right now. I am a walking corpse, it feels. So I think I'm going to actually end stream here. Okay. Been doing a lot of shorter streams recently. Um hold on. Hold on a minute. Yeah, I mean Mondays are great, but like Wednesdays and Thursdays are pretty rough. Um so I'm gonna have to figure that out. But today I think I am gonna end the stream. So I guess we got done what we could. I'll be live tomorrow. We can keep working on this stuff. The goal for tomorrow will probably be to like figure out this pressure dilemma. Oh, it's kind of cool. It's like a new problem every time though that relates to like actual physics. Interesting. It's an interesting way to like learn about physics. Like whenever you try to simulate something on some level, you gotta learn a lot about the thing. So I guess this is just a good way to learn physics. Um, yeah, some probably mainly involving figuring out the pressure, unless I just decide to do something completely different. But if we're gonna work on the chemistry engine, that's most likely what I'd focus on. Yeah, for today I am going to end the stream. Before my brain just completely short circuits. So thank you everyone who stopped in. I'll be live tomorrow. Yeah. See you later. Take care.